Okay, so in this session we're working through the Paper 2 Maths Intermediate Tier from November 2018. So this is the last session now before your final maths exam. We've pre-filled in the front, so we're still working with aiming for half marks for a C, 52 for a B. Half marks pretty much takes us up to the end of question 9. If we had full marks up to there, then that would get us safely a grade C. So I'll stop as usual recording and take a break at the end of question 9. We filled in the front with all the extra formulae that it's worth remembering, and as I've said before, if that's the first thing you do when it's all fresh in your head when you go in, then you haven't got to worry about remembering them later on. So question 1. It's calculate. It's calculator allowed paper, so long as you know how to use your calculator, this should be easy. But there is an extra little sting in the tail where once we've got our answer, they want us to round it using significant figures. So let's get our answer first of all. So 8.2 squared plus square root of 13. So on the calculator, it looks exactly the same as it does on the paper. Press equals. Write down the string of decimals. You don't have to write the whole thing down, but well beyond where you're going to round, so the examiner can see that you've actually done this bit of the maths right, even though you may mess up on the rounding. So it's significant figures, so we start counting straight away. So the 7 there is the most significant because it represents 70. Then the 0, because that keeps the 7 in the place of the tens column. So to two significant figures, my answer is either going to be 70 or 71. You look at the next one along, 0.8 pushes it closer to 71. So to two significant figures, your answer is that. Find 57% of 83.5. The only button that this amazing calculator doesn't have is an of button. The of you have to replace with the times on your calculator. But the 57%, we've got a percent button. So this again, I can type in exactly as I see it. 57, shift open bracket to get the percent, times 83.5. So that's 47.595. Again, there's an instruction to round it, and this time the rounding is a decimal place. So we start counting after the decimal point. Significant figures we start counting straight away, decimal places after the decimal point. So one decimal place is there. So we're either going to have 47.5 or 47.6. You look at the next digit over, it's going to push it closer to 47.6. So marks for those, straightforward. 1 mark if you've got the calculation correct. 1 mark if you've got the rounding correct. If you just wrote 71 down, you'd get 2 marks because it's right. But if you did something wrong there and you don't see the full string of the answer, you may end up missing out on a mark. And similarly for this one, there's a method mark for turning the of into a times, so correctly writing that in the calculator. There's 1 mark for the full answer and 1 mark for the rounded answer. So that's how that's calculated. Question 2. Circle either true or false for each statement given below. And they're all to do with similarity. Now when shapes are similar, it means that any enlargement, the same enlargement happens for every side in the shape. Okay? So for a circle, it's only got one side. So if I've got a circle there and I make one twice as big, it's going to be similar because the whole shape is twice as big. The same with squares, because all the sides are the same length. If I'm doubling one side or tripling one side, I'm tripling all of them. So that's true. But with triangles, if it was an equilateral triangle and you doubled or tripled or whatever every side, they would be similar. But if you had a triangle maybe with that being 1 and that being 2, I could double that side and not double that side, so they won't be similar. So that one's false. The same with rectangles, because they're not all the same length, they're not all going to be similar, so that one's false. Now, because that word is there, regular, it means it's the same as a circle or a square. All the sides are the same length, so if you increase one, you'll increase them all. If that word regular wasn't there, the answer would be false. But because it says regular, it's actually true. Okay? So, 3 marks if you get all 5 correct, 2 marks if you got 4 out of 5, 1 mark for any 3. One day, Gwyn was asleep for 8 hours and awake for the remaining 8 hours. Draw an accurate pie chart to illustrate this information. What surprised me when I marked this, when you did it in class as a test, was some people couldn't decide whether there were 12 hours or 24 hours in a day. Okay, a day is 24 hours. So 8 hours would be asleep, out of 24, and then change that into an angle. I want to times that by the total number of angles available, which is 360. So on my calculator, 8 out of 24 times 360, 120 degrees. So the asleep part is going to be 120, and there's only 2 slices in this pie chart, so what's left is going to be the other one. You need to draw a starting point. We tend to draw it vertical just to come in line with bearings, really. You could draw the starting point any way you liked. And we need to draw a 120 degree angle. We put the center of the measurer at the center of the pie, and you line the 0 up with the line of the slice. When we're measuring, if we're going in this direction, we're going along the outside scale, so we're going 0, 10, 20, up as far as 120, which is there. And we need to then make sure that we label it. And that's that. So that's quite a straightforward pie chart because there's only 2 slices to it. So 3 marks for drawing it, 1 mark for labeling it. So that's quite an easy 4 marks there. Question 4. Choose any number. Show that 1/5 of 25% of your number is equal to 1/4 of 20% of your number. If they're asking you to show something like that, even if they don't give you a number, sometimes they don't say choose any number. Pick an easy number. Pick 100. Yeah. So for 100 or 10, but 100 is usually better. So as I said earlier, on the calculator, I can write a fraction. I can't write of, so that has to become a times 25% of 100. So that's what's going on to the calculator. Fraction 1/5 of 25% of 100. So that works out to be 5. And I now want to show that if I work out 1/4 of 20% of 100, I end up with the same thing. And I do. So they are the same. So there's 1 mark for choosing your number and finding 25% of it, or 1/5 of it and 1/4 of it. So doing 1 stage. Then there's another method mark for doing the 2nd stage, times in 25%, and 2 marks for showing that you end up with 5 each time. So they're just little skills checking that you know how to use all the functions in your calculator. Question 5. So this is our OCW question. In this question, you'll be assessed on the quality of your organisation, communication, accuracy and writing. ABC is an isosceles triangle. So that's a trigger word for triangle that has got 2 equal sides and 2 equal angles, and the equal angles are at the bottom of the 2 equal sides. Calculate the size of CBP. So C to B to P is this angle here. It's the angle you're turning once you've travelled from that line, and then you have to turn to go to that line. If it was the inside angle, it would have been CBA. So that's what we have to work out. But we've got to communicate what we're doing. So we're going to say isosceles triangle, so base angles are equal. 180 take away 76 equals 104. So these two together add up to 104. So angle CBA equals 104 divided by 2 equals 52 degrees. CBA and CBP lie on straight line equal 180 degrees. So I'm communicating that this angle and this angle are on a straight line, so they add up to 180 degrees. So CBP equals 180 less 52, 128 degrees. Now I could have done that without writing a word and got 3 marks. Extra 2 marks are for just writing down the facts that I'm using. So it's an isosceles, the base angles are equal, or the angles at the bottom of the equal sides are equal, or even CAB equals CBA, however you want to write it. And then lying on a straight line equals 180. So the maths for that, there's 1 mark for working with the isosceles triangle, and 1 mark for getting 52 degrees, and 1 mark for ending up with 128, and then plus your 2 OCWs for how you organize it. Okay. Question 6. Solve an equation. So when you solve an equation, whatever you do to one side, you have to do the same to the other to maintain the balance, and what you're trying to do is to get the unknown on its own. So in order to get that unknown on its own, I have to undo a divide by 2, which means I have to multiply by 2. And if I multiply the left-hand side by 2, I have to multiply the right-hand side by 2 as well. That leaves me M on the left hand side and 4.8, 9.6 on the right hand side. Okay, so the most common mistake to make with that one is people try to think I'm going to divide 4.8 by 2. So the most common wrong answer there would have been 2.4. So that's a single step equation. With part B, the trigger word is factorize. So factorize is doing the opposite of getting rid of brackets. It's creating brackets. You're looking for, in each part of each term in the expression, common factors. So I'm looking for a common factor between 6 and 15, which is 3. So you could write that as 3 times 2 times x, take away 3 times 5. And then if you imagine that we're pulling out the 3 because it's common, what that leaves me is 2 times x from the first bit and 5 from the second bit. You can check it by multiplying it back out. So 3 2s are 6x, 3 5s are 15, positive times a negative, signs are different, answer's negative. For the second one, there's no number that's common, but the y squared means y times y plus 4y. So there's a y that's common to both. And if I take a y out of both, it leaves me y plus 4. Nth terms, sometimes they ask you to find them from a sequence, sometimes they'll give you the nth term and you have to use it. So to work out the value of the 6th term, I'm replacing n by 6. When I replace a letter with a number, it goes in a bracket, so I don't get muddled up writing it as 36. To get rid of the bracket, I know I have to multiply, so that becomes 18 take away 20, which is negative 2. Do you want to grab one? We're just finishing question 6. Oh God, a long day for you. So we're looking now at the last statement. Consider the following statement: there are no odd numbers greater than 50 in this sequence. Show that this statement is incorrect. So they're not asking you to prove whether it is or isn't. It's telling you it's wrong. So all you have to do is come up with an example where you end up with a number greater than 50 that is going to be odd. Okay, so try one. Try 25. Okay, so let's try 25. So 3 lots of 25 take away 20. 3 lots of 25 is 75. Take away 20 is 55, which is an odd number. Where did I get it from the rule? Yeah, so the rule is 3n take away 20. So I've got to pick a big enough number that when I multiply it by 3 and take 20 off it, it's going to be over 50 and be odd. So it just so happened the first one I chose works. That might not have worked. I might have picked something that came out to be even, in which case I've got to try another one because I know it's wrong. They're telling me it's wrong. I've just got to search for a value that means it ain't going to work. So that's a bit of a weird one, that one. So marks for that. 1 mark for each of these because they're 1 mark questions, so they're right or wrong. Well, for all of them actually. Not many on the intermediate paper would have got that very last mark. Question 7. 2 fair spinners are divided into quarters as shown below. One spinner shows the values 10, 20, 30, 40, and the other the values 1, 2, 3, and 4. The 2 spinners are spun and the values shown are added together to form a number. For example, the diagram above would show the number 31. So 30 and 1, 31. Consider all the possible numbers that can be formed. Calculate the probability that the spinners will form a number that is a multiple of 7. Well, first of all, we need to get our list of all the possible outcomes. So, as I've banged on plenty of times in class, with this sort of thing, you need to be methodical. So if we start with 10 on the first spinner, we could have 1 on the second spinner, giving me 11. Keeping the 10 on the first spinner, and considering now all the possible outcomes, I could have 10 and 2, 10 and 3, 10 and 4. Then I think about, let's move the second spinner. So the second spinner could be 21, 22, 23, or 24, and then we're on to 30, and finally on to 40. There's no other possible outcomes that could happen. So now, what's the probability that the spinners will form a number that is a multiple of 4? So multiple of 4, what's the probability that it lives, multiple of 7 in the 7 times table? So I know I've got 14, I've got 7, 14, 21, 28, 35, no, 42. So there are 3. So the chances of you getting a 7, so P bracket 7 equals 3 out of all the possible combinations. So I got 4, 8, 12, 16 possible combinations. So what they're looking for is 3 out of 16. Two marks for listing all the possible outcomes. 1 mark for having something out of 16. And 1 mark for having the correct 3 out of 16. But if you had got a different number of outcomes there because you'd missed something out, so let's say you ended up with 15 outcomes there and you had out of 15, you get that mark because you've shown where that's come from. So they'll penalise you there, they won't penalise you again there. Okay, so you could end up with not listing them all and still earning those 2 marks. Okay. Question 8. Calculate the approximate difference in length between 1 mile and 1.5 kilometers. Give your answer in meters. Okay, that means at last something that I've written on the front actually now is useful. 8 kilometers is approximately 5 miles. I want to be working in meters, and I know there are 1,000 meters in a kilometer, so I can write that like that. If I know 5 miles and I want to work out 1 mile, I have to shrink. I've got to reduce that by 5. It's not subtract, it's always multiply or divide. So I have to divide by 5. But if I divide that by 5, I have to do the same to the other side of the equivalence. So what I've got to work out is what 5 into 8,000 is. So 5 goes into 8 once, remainder 3. 5 goes into 36 times. So 1 mile is 1600, roughly 1600 meters. The question wants me to find the difference in length between 1 mile, which is 1600 meters, and 1.5 kilometers, which, going back to there, I know there are 1,000 meters in a kilometer, so 1.5 will be 1500 meters. So the difference between 1 mile, which is 1600 meters, and 1.5 kilometers is going to be about 100 meters. So that's quite a tricky one, that. Yeah? There's a lot going on there for 3 marks. And there's another conversion here, which is metric to metric. Now, if you're not sure about this, think about what is happening with area. Okay? If we've got 4 meters, that could be a rectangle, which is 1 meter by 4 meters. Or it could be a square 2 by 2, doesn't matter. Okay? The point is that if we wanted to work out what that is in centimeters, I know that 4 meters is actually 400 centimeters. And 1 meter is 100 centimeters. To work out that area, 1 times 4 gives me 4 square meters. But in order to work in centimeters, I'm actually doing 100 times 400, which is 4 followed by 4 zeros in square centimeters. The most common mistake people make is they only multiply by the 100 once. So they'd say, well, that's 400 square centimeters. You have to multiply by the 100 for each side. And if it was volume, if you were turning 4 meters cubed, then you'd be multiplying by 100 by 100 by 100 to get it. So if it's a volume question, you'd be taking whatever the cubic meters are and multiplying it by 100 3 times for each side. So that was a nasty old question there, for especially given us in the overlap with the foundation tier as well. So there's 1 mark for basically remembering that equivalence and dividing it by 5. 1 mark to get the 1600, and 1 mark for ending up with 100. And the method mark here is for timesing by 100 twice to get that answer. Not a nice question. Question 9 then. So this is the last of the D into C questions. So ABCE is a square. So if ABCE is a square, if that's 6.4, I know all the other sides within that square are also 6.4, which may help us. Calculate the area of the shape ABCDE as shown below. So I've got this shape that's made up of a square with a triangle sitting on top of it. The area of the square is going to be length times width, which is 6.4 times 6.4. So that bit's nice and straightforward. 40.96 centimeters squared. So I know the area of the square. I now need to find the area of the triangle, and I know the formula for the area of the triangle is half base times the height of the triangle. Well, the base is 6.4 because it's sitting on top of the square. So I've just got to work out what the height is. And the height is this distance here. Well, I know that it's from sort of tip to toe, it's 10.7, and it's 6.4 from there to there. So the height is going to be 10.7 take away 6.4. Which is 4.3. So to work out its area, I can type that into the calculator exactly as I've written it. So half times 6.4 times 4.3 is 13.76. So to answer the question, the total area is going to be the area of the square which is 40.96 plus the area of the triangle, (54.72) square centimeters. Now it's not an OCW question, and it's not asking you for the units at all. Okay, so you don't need to put any of those units in, and even if you put the wrong units down, it wouldn't matter. It's just the more times you write them, the more chance you are of remembering. So 5 marks for that question, 1 mark for the area of the square, 1 mark for finding the height of the triangle, a method for the area of the triangle, so for doing this bit, and an answer mark for 13.76, and then a final mark for adding those together. So even if you can't get through the whole thing, but you think, oh, I can work out the area of a square, make sure you write it down. I can find that height. Okay, so that takes us to the end of the E to CD questions. We take a quick break there.